How's everyone doing? Good, good. How was the homework 3? Good. How many of you are done with quiz 1? Okay, how many of you are still working on it? Okay, so make sure to finish it by tonight because deadline is like 11:59 p.m. and you don't want to put it like last minute, like at 11 p.m. in case something happens and you want to contact me, technical difficulty or whatever. So make sure to just like be done with it like sooner so you can email me if there is any questions. This lecture, and also, so let's start with the attendance. So we also allow other students to join so they're not missing the lecture. The reason, in my Chem 101 class, I usually do attendance at the end because there are some students that as soon as they're done with attendance, they leave the class. So, but I'm like more confident with you guys, so I don't think that when you're done with the attendance, you just leave the class. I hope not. I mean, if that's the case, or like you have to go, just like email me in advance so I know that it was like because of a reason or like it was excused. Okay. Does anyone have these handouts that Dale gave us the other session? Any of you not having these? I have like extras, so okay. Oh, it blew because I actually loved it.
I think it's the one. If it's hydrogen, it's hydrogen. I like the science one.
You can also email me if you realize that you don't have them. Yes, we talked about this briefly last time. Not briefly, we talked about this last session, but I'm going to review that. And don't be afraid if you're answering the question wrong, or you're not confident. I just want to see how many people know the answer. You know what I mean? So I don't grade this. It's just like, sometimes in these questions I realize that something I didn't teach well, or something I should emphasize in the class. So this is the whole purpose of the question. Okay, everyone's done with the attendance? Okay. Again, if you had like difficulty, I try to go through this slide at the end of the class too, in case some students were late and they missed that. But just you can, come to me after the class too, so I make sure you. What am I doing? If you didn't go through the attendance, whether just like go through it now, or if you have a class that you should run into, just like come to me and then give me your name, so you can just run to your class, I guess. Have a nice weekend. Have your attendance. Okay, so I usually go through the assignments in the class. So how many of you are thinking or think that this is useful if I just go through the homework assignment in the class? How many of you think that it's like boring or like you already know the answer? It's not an efficient use of our class time. Okay, so everyone's good that I talk about them? Okay. So the average score of the homework assignment was like 81. And as you see, usually like the average starts to drop down as we progress with the course. So, but the average time was like 38. I think the last time it was like 17 minutes, like 20 minutes, something like that. Anyway, so I have like all the questions to save also time, and I'll also be able to record them. I have like just a screenshot of the problem. So to just like review for students that they didn't answer this correctly, and also for all of you to review them. Can you tell me that what is the first step when I want to name alkanes? Longest carbon chain. So should I go left to right or right to left? Left to right, right? Can anyone tell me why? Yes?
Because of the placement of the branch.
Exactly. We go to the direction that we encounter this branch first, right? And this is how we name the carbon. 1, 2, 3, 4, 5, 6. And we only name the carbons in main chain, not the branches. Is that clear? Okay. And here, what group is this? What substituent is the name of CH3? Methyl. Remember that if you have an alkane and then we remove a hydrogen, it becomes like alkyl. So methane became methyl. And here, what is the general name of this alkane? So we have like 6 carbons, so it would be hexane, right? So this is something that the students get confused, that they count all the carbons. We don't care about all the carbons when we name the alkane in general. I mean, we care about this CH3 here, and we call it with this branch here, right? So we name it eventually, but we just count the number of carbons in the main chain. So this is a hexane. It's not pentane, it's not like heptane, it's just like hexane, okay? And you see which carbon you have like your branch attached to, and then you call that like 2. You name that carbon 2, and then you put a dash. I mean, I just like messed this up, and then you add a dash here, 2 dash, and then name the name of the substituent, methyl hexane. And if you have like another group here, CH3, what would this be? So if I want to write the name, this name here, what would I write?
2, 2, 2, 2.
Uh-huh.
Dimethyl.
Okay.
Dimethyl.
Dimethyl hexane, right? And then you put the comma in between them when you have like, different carbon or different carbon numbers that they have like functional groups attached to, and then you put dash when you want to distinguish or write the name of the compound. And then if you have 2 of methyl, you write like di. Remember, di is 2, tri is 3, tetra is 4, right? But this is how we solve this problem. Everyone good with this? So let's go to the second one. What is the first step? Longest chain, right? So what is the longest one? So one possible way is just like we go like this, right? This chain here. So if you also go the other way, it would be 1, 2, 3, 4, 5, or like the other 1, 2, 3, 4, 5. That can be 2, right? But I guess this is like a straight line. This is more straightforward. And do you remember that if we had like multiple ways to go, like this problem that I only can go 1, 2, 3, 4, 5, or like 1, 2, 3, 4, 5, or like the other way. What did I do? Here or like here, right? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If there are like multiple ways, which one do I prefer, or should I choose? More branches, right? In this case, all of them gives me like the same number of branches, so I just go with this one, and then this is like a straightforward too. I have like 1 branch here, 1 branch here, okay? So now, should I go left to right or right to left? Why should I go left to right? Exactly. So if I name this way, it would be like 1, 2, 3, 4, 5. If I go the other way, it would be like 1, 2, 3, 4. So I want to reach that sooner. So this is like really similar to what we just wrote there. It's kind of like that was hexane, this is pentane. This when I added a CH3 here. So what would be this name? Yes, so it's pentane. It has, like, remember, main chain. We count the number of carbons in that chain. And then here, how many methyl groups do I have? So I write dimethyl, right? And what is the carbon number that methyls are attached to? 2. But since you have 2 of those, you should write 2, comma 2. If you write 2, if you write just like 2 dimethyl, this is not right. Because you have 2, you should write 2 and 2. Does that make sense? Any questions about this? Okay. So now let's go to this one. As we said, when we don't write, when we just like carbon, what does that mean? Does it mean that this compound only has carbons? We also have hydrogen, right? But to save time, we just don't write sometimes all the hydrogen. So how many hydrogens this carbon is attached to?
3.
Why 3?
Carbon.
Yes. Carbon has, like, it's in group 4A. It has 4 valence electrons, and its valence is also 4 because 8 minus 4 is like 4. It can form 3 bonds. It already has 1, so it can form 3 more with hydrogen. What about this one? Again 3, right? Because again, it has 1 bond. It can form 3 more bonds. Is that clear? And can anyone tell me, can I have like this bond? Can carbon and hydrogen form a double bond? Why not? What's that?
Hydrogen only has one to give.
Exactly. Hydrogen, the atomic number is 1. It has like 1 electron in its valence shell, and it reaches duet, not octet, right? So it can form 1 bond, because here we have like, I don't know why it switches to the eraser. I don't know. So here 1, 2, 3, 4 electrons are shared, but hydrogen can maximum have like 2 electrons in its outer shell. So this is wrong. So that's why all of these ones are like single bonds. Is that clear? So what about this one? How many hydrogen can be attached to? What about this one? What about this one? What about this one? Exactly, right? 1, 2, 3, 4. What about this one? What about this one? What about this one? What about this one? Yeah. So it has 1, 2, 3. It can have 1 more. So now, if you want to name this, first of all, what is the longest chain? Just like this one, right? And how many carbons it has? 1, 2, 3, 4, 5, 6, 7. 7, right? So what would be the name of the alkane? Heptane, right? And when you're solving problems or like questions, even if you're not sure, you can always do elimination, right? So if you just know that, remember that she said that in the class, that we just count the number of carbons in the main chain to name the alkane, right? So you can just eliminate at least decane, this, option. Sometimes you can eliminate more. Okay, so should I name left to right or right to left? So here I encounter the branch to, if I name this way, it would be the 1, 2. The second carbon, I encounter the branch. And also if I go this way, it would be like 1, 2, right? So these numbers are the same. But why do we go left to right?
The next carbon chain is the closest.
Yes, so if you are like the same distance from both sides, you go from the direction that you encounter the third branch sooner. So if I go this way, I have like 1, 2, 3, 4, 5. But if I go this way, 1, 2, 3, and 3 is lower. So I go left to right. Does that make sense? Okay, so I name these as 1, 2, 3, 4, 5, 6, 7. Can you see that color? Kind of. Okay. So 1, 2, 3, 4, 5, 6, 7. Okay. So if you want to name this, first of all, what groups or substituents do you have? Methyl, right? All of them are methyl. And don't confuse, here these methyl groups are like close to each other. Don't be fooled, because in order to have like the ethyl, they should be attached to each other. These are like attached to different carbons. So they are like separate methyl groups. And then we talk about ethyl if we have them in the next example too, I think. So here we call them trimethyl, right? Is that clear? Because we have like 3 methyl groups. And now we want to see which ones are there. So here, now the numbers that I have here is kind of messed up. But can you guys distinguish that here 1, 2, 3, and here is 6? So what would be the numbers here? 2, right? 3, 6. And then we separate them with commas. And then we separate those with dash to write trimethyl. Good? Okay. And most of you got it right. So I apologize if it's just like repetitive. So what about this one? So this question was giving students a harder time. So here, just first of all, tell me how many hydrogens I have attached to this carbon. How many here? How many here? How many here? 2, right? I have 2 here. Okay, what about here? Right? We have like 3 here, we have 1 more. What about here? What about here? What about here? This one? This one? Yeah. Okay, so can anyone tell me which one is the longest chain? So I guess the most straightforward one is like this one, right? Can we go other direction? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 3, 4, 5, 6, 7. I guess we can also go 1, 2, 3, 4, 5, 6, 7, and then the result would be the same. We would be having like 2 branches outside, right? So the results are the same. You can choose any of them, but I guess for me personally, it's just most straightforward to just like have the straight line in front of me. But the other one works too. So if I go with this one, I will be having this and what was it? This one as branches, right? So you see what I'm talking about? So here, this branch is attached to this one. So that's why is ethyl, is not 2 methyls. Does that make sense? So in the previous examples, we had like 2 branches, separate ones that they were attached to carbons. Here we have like, again, we have like 2 groups. One of them is methyl, the other is ethyl. Does that make sense what I'm saying? So here we have like CH2, CH3. So basically it's like C2H5. Can anyone tell me what is the name of this? C2H5. Ethyl, right? Because it was like ethane, remember C2H2N plus 2, so C2H2 multiplied by 2 plus 2, so C2H6 is ethane, right? And if we drop a hydrogen and change it to 5, would be like ethyl. Does that make sense? Any questions? Okay, so now here, remember, so when we go like those 7 rules that we have to like reach to this point, and also to distinguish the name of the carbon. So should I name the carbons from left to right or right to left? Which one? So if if we go right to left, you reach the methyl group in the 3rd carbon. If you go to left to right, you again reach the ethyl group with the 3rd carbon. So we go with the one that is alphabetically prioritized, right? So we go left to right. So we write 1, 2, 3, 4, 5, 6, 7. So we write 3 ethyl, and we separate all of these with dashes. 5 methyl. So you see that this methyl is attached to the 5th carbon. And also the name is heptane. So this one is the answer. Does that make sense? And even, if in some circumstance it was like the numbers here were different, you always write ethyl first and then methyl. So when you want to also write the name, you prioritize alphabetically. Does that make sense? But even if you had like ethyl, dimethyl, still you would write ethyl first. So you don't consider D alphabetically with like E. You consider ethyl, methyl, the groups themselves. Is that clear? Questions? Good. Okay. Now this one. So, first of all, what is the name of the alkane? The base name of the alkane in this structure? Butane, because the longest chain has like 4 carbons, right? As I said, you can also consider another directions, but this is a straight line. I just go with that, right? So this is what I'm talking about, that automatically you eliminate the hexanes, right? So in your exam, if you're like out of time and then you have to rush, one way is to just like choose between these two, and then 50% you'll get it right? But I mean, I give you enough time in the exam, so if you study and then just like go through the materials, you shouldn't have any problems. Anyway, so now you have 2 branches, right? What are they? Methyls. And there are 2 of them. It would be dimethyl, right? And should I go left to right or right to left? Doesn't matter. So you can go from either direction. And in either direction, you'll be having like 2, 3 dimethyl butane. Good? Questions? Okay. So now this one. So, we eliminated the hydrogens before because of the brevity and then kind of like save time. You also can eliminate the carbons. And as we said, any of these points here, they have a carbon, right? Remember, we talked about this briefly. So I encourage you to write the structure first and then name the compound. So how many hydrogens here? Here, 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 this one, you see 1, 2, 3, 4, so it's all set. It has like 4 bonds. Okay, now we want to find the longest chain. So which one do you think it can be? Like 1, 2, 3, 4, 5, 6, 7. 4, 5, 6. If I go like this way, I just don't want to mess this up so much. If I go this way, would be like 6, right? But if I go like this way, 1, 2, 3, 4, 5, 6, 7. It can also be with like, it's possible. But as I said, I always go with the one that has like the lowest. Yeah, I didn't mean to delete alt, but somehow I did. This is the good thing about like Word and PowerPoint, those things. I can just like undo what I did. Anyway. 2. If I'm just like writing something sometimes by mistake, just like let me know. This is right? Okay. So one possible way, so I don't have my image so cluttered, would be this, right? 1, 2, 3, 4, 5, 6, 7. So what is the name of this alkane, the base name? Heptane, right? So again, this option would be eliminated automatically. And we have like branches. 1 here. What is this group here? Ethyl. You see, when you solve more problems, you know, it becomes like more comfortable. Now you don't even think about it. You see like 2 carbons, 5 hydrogens, you just say ethyl, right? So what are, you know, these ones? Exactly. So there are like methyls, each of them, and you have like 2 of them. So dimethyl. And which side should I name this? Should I go left to right or right to left? I should go left to right because I encounter methyl, or I encounter a functional group or like substituent first. So don't get confused. Here we don't go alphabetically. When we want to write it, we write ethyl first. But when we want to name the branch or name the carbons in main chain, we go left to right. 1, 2, 3. Now these ones would be confusing. Okay. 1, 2, 3, 4, 5, 6, 7, right? So you say 2 and 2, right? Dimethyl. And here you have like, you know, the 4th carbon is attached to ethyl. But when you want to write it, you write ethyl first because alphabetically first write ethyl. Does that make sense? Any questions? So when you want to name the carbons, you go to the direction that you encounter the branch first. So that's why this is like 2 and 2 dimethyl. But when you want to write it, you write ethyl first because alphabetically is prioritized. Good? Any questions? Okay. So if I give you something like this, first write the structure. This is like the abbreviated a structural formula, right? Or like, yeah. But have it like the expanded version. So if I want to write, you know, so you have CH3 3 times. You know that in your structure, CH3s should be like close to each other, right? So if I write C, and the other thing that we learned in this course is that carbon has the ability to just form bonds between the same atom. Like you can have like carbon, 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 right? And the ability of an element forming bonds with the same element with itself. What did we call that? Anyone remember? Catenation, right? So we can have like carbon, carbon, carbon. So I just encourage you to just write some carbons for the ease of writing, I guess, or like, you know, you'll be faster. And here you see that you have CH3 3 times, and you know that probably you should have a branch, right? Because CH3, if you just like attach 3 carbons to each other and write this, what would this be? Yes. And then you can call this C3H8. What is this? Propane, right? So here I don't have, if I had just like only 2 of these, it would be CH3 right? But I have like, so this is something, again, with practice, you realize that when you're writing these structures, the middle carbons are usually CH2 or CH because they have bonds with carbons and they already have 2 bonds, so they can have 2 more, right? So that's why I'm, you know, giving you, instead of like 10 homework problems, like 20, I give you more, so you see more examples, so you become more comfortable with this. Anyway, so here, if I just want to write for now, here I have like, just like switches to this. Okay, so CH3 3 times. In order to do that, so how can I write CH3 3 times next to each other? Does that make sense, my question? So what is number of hydrogens here? 2, right? What is here? So you see, I want to have CH3 3 times and just C, just carbon, not CH, right? So in order to only have a carbon, I should have like 4 bonds here without any hydrogen. This is not what I meant. So in that way, this one would be now just C, right? Are you with me? Do you know what I'm trying to do? I'm trying to write CH3 and try to figure out. The only way that I can do that is if I write a branch here, right? So now if I write this, what would be this number of hydrogens here? What would be this? And what is this one? Or I guess let me just like, if I eliminate this one here, and if I can manage this to work. Okay, so as how it is, what is the number of hydrogens here? 1, right? Because I have like 3 bonds, and then I need 1 more hydrogen. So if I write this as it is, it would be CH3, 2 CH. Is this what I want? No. So what should I do? I should put another ethyl, right? So if I put another ethyl, how many hydrogens? Okay. Now let me go back and then, okay. So now for this structure, crooked structure that I have so far, what is it? The abbreviated structural formula. Can anyone tell me for just like what I have here? How many CH3s I have? And then what is this one? So I got what I wanted so far. Did you understand how I got there? So I realized that if I just have like, when you want to write the expanded chemical structures, just have some carbons, just do catenation, right? Or just like write some carbons and count the hydrogen. And then kind of think that how I can have like CH3 3 times is kind of like if some of them are branches, right? And then kind of like count the carbons, remember, or like bonds between carbons and also hydrogen, and remember how we did. Kind of like we do reverse of what we were doing before. Previously we had the structure, we would count. Now we want to figure out how to write the expanded structure. So now, if I just like eliminate these bonds, so don't confuse us. Okay, how many hydrogen here it should be? How many here? 2, right? And then how many here? But here, so you see that we have CH3 3 times, C, CH2, CH2, and then the last one is CH3. So we don't have any carbons after this. We have like just till here, right? And how many hydrogens we have attached to the last? Okay, and always check. So here, if I ask you what is the abbreviated structural formula for this, what would you say? Is it the one that we wanted to find? Okay. Did all of you understand what I said? Kind of? How many of you have issues still with this or think you should practice more? Okay. I mean, it's always good to practice, right? Now we want to name this. You see that now the structure is more tangible. Now we are like used to this structure. What is the first step? Longest chain, right? How many carbons it has? 5. So we have like pentane, right? So you automatically eliminate the first one, right? How many branches? What are they? Exactly, we have 2 methyls, so it would be dimethyl. Should I name left to right or right to left? So 1, 2, it would be 2 and 2 dimethyl pentane. Good? You see that it's not that easy to write it just looking at the abbreviated structural formula, right? Okay, so now that I'm just kind of like behind what I wanted to do, I try to go faster. So now write this one. So CH3, right? And then we have CH2 2 times, right? And we have CH3 again. Again, I advise you to just write, when you see you want to have like the expanded structural formula, you see like 1, 2, how many carbons you see here? 4, right? 1, 2, 3, because when you have something in parentheses, you multiply the numbers. So 1, 2, or not that one, sorry, not this hydrogen, carbons. 1, 2, 3, 4. So just write 4 carbons and then try to attach hydrogen and then see what happens. And then if you had difficulties like the previous one, we try to adjust, right? So, and again check CH3, CH2, 2 times CH3. What is this one? Butane, right? Here. So don't get confused, This is just like butane. Any questions? Okay, this one. So this is like more straightforward. So what is this name? 1, 2, 3, 4, 5. So you can just eliminate this one. So what functional group or like substituent do you have? And the second carbon, right? Let's go to this one. So this one is just trickier because it tells you, is this IUPAC name correct? So how do you know that if it's correct or not? We should draw the structure, exactly. So what is ethyl? Exactly, so it's like C2, CH3, CH2, right? C. And butane, what is butane? Right? Because C4, H2 multiplied by 4 plus 2, right? Anyway. So we had like butane in the previous picture or slide too, right? So I have like butane here. Let's see if I can just like, if I have like butane here, and it says that in the second carbon, imagine I go left to right, right? This is how I'm writing this structure, and I encounter the branch sooner here in the second carbon, and I have an ethyl group, right? So it would be like I attach ethyl here. So this one, what is this? C2H5, right? Or like CH2, CH3. This is ethyl. Is that clear why? This is, I just attached an ethyl group to the second carbon, right? Because this is what I was given, 2-ethyl butane. So I put the rest of hydrogens as well, or yeah. So how many hydrogens should be here? So 1, 2, 3, how many? 1, right? How many here? Or I guess I just put the hydrogens both sides, right? And then here again. Is that clear what I did so far? I just wrote what I was given. So now if we want to name this compound, what is the so here in this question we assume that this is the longest carbon chain, right? Because it was like butane, it has like 4 carbons. But is this the longest chain that you see in this structure? So this one, if I tell you, what about this one, this chain, right? It has 1, 2, 3, 4, 5 carbons, right? So this IUPAC name is not correct, because we had a structure and then we named it somehow that we didn't have the longest chain. Does that make sense? So I asked you guys to write this structure and then bring it to the next class. And then I'm going to ask you what is this structure. Does that make sense? So the correct name of 2-ethyl butane, if this name is not correct, what is the correct name? Okay? So here, again, it's kind of like similar. It asks you, is this correct or not? So again, you write heptane. and you should have 7 carbons, right? 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3, 4, 5, 6, 7. For the second one and fourth one, we have methyl groups, right? CH3, CH3. Okay? So now you can also write the number of hydrogens here, or this one is 1, 2, 3, 4, right? 2, 1, 2, 2, 3. Okay, so is this one the longest chain? Right, so this name is correct. Does that make sense? We're good with this one? Okay, so now the next question is kind of like similar to what we were doing. It was just like 3D image and 3D structure. So you can see here we have like, you can do exactly the same thing. You find the longest chain that is like has 4 carbons, right? It's butane. So it's one of these 3. And then you have like 2 methyls, right? So it would be dimethyl, and the number of should you name it this way? I was looking at this one and I was like, okay, this, or like I was like, this one is not correct because I was looking at the wrong answer. So would you name the carbons left to right or right to left? Right to left. So it would be 1, 2. It would be 2 and 2 dimethyl butane. Good? Any questions? Okay. So as you saw, I went through the questions that was giving the students a hard time for the previous homework assignments, and I repeated them. I had like 0.5 points, so lower points for them because they were repetitive. But still, some students were getting them wrong, you know. So it's possible that they were like the same students, or just like some students just make mistakes. So make sure that you learn the, you know, homework problems and quiz problems. You have like lots of, you know, 20 questions each session. So the chances of you seeing the exact same question in your exam would be really high, right? So don't, you know, just learn every homework problem. So what is a kernel? Do you remember? Anyone?
Nucleus and all of the extra shells that aren't valences.
Exactly. So nucleus and filled shell electrons, or like non-bonding electrons, or non-valence electrons, right? So when we were writing like Lewis structure of oxygen, for instance, we would say that we write oxygen and this represents the kernel, right? The nucleus and filled shell electrons, and valence electrons we put like around it. And how many valence electrons oxygen has? 6, right? Group 6A, remember? So if I give you the exact same question, you know, tonight or tomorrow for like next homework, make sure to know this, okay? Kernel. And then what is the maximum number of electrons that can occupy third and fourth shell respectively? So again, this is like a question that is repeated. So, and when I asked you like third shell, I mean n equals 3, right? So what orbitals do we have in n equals 3? So because n is equal 3, you will be having 3 different subshells, or 3 different types of orbitals: s orbitals, p orbitals, d orbitals. What about n equals 4? Exactly. So what is the maximum number of electrons in s orbital? What about p? What about d? 10, right? You have like each d subshell, it has like 5 orbitals, each of them can have 2. What about f? 14, right? You have like 7 orbitals in like f subshell, it would be like 14. So you count this number. What is 2 plus 6 plus 10? 18. What is 2 plus 6 plus 10 plus 14? 32. Okay? So make sure to know the answer to this question, because I may ask you again in the next homework problem. So is the following statement true or false? A molecule consists of 2 or more atoms joined by chemical bonds. Why it's false? Covalent bonds. Because chemical bonds, ionic bonds, are also chemical bonds. So I can't say technically if they also have ionic bonds, they would be molecule. No. Right? So that's why this sentence is wrong. It should be covalent. Remember, we said that chemical bonds consist of covalent bonds and also ionic, right? So again, being in the middle of the periodic table, which element is neither strongly electropositive or electronegative? Carbon, right? And in multiple choice questions, you always look for the answer that is best, right? If I didn't have carbon, you might, we would have argued that maybe like nickel is the best option among the other ones. But when you have carbon, we said that our course is like carbon compounds. This is like something really specific to carbon. So it can like lose or gain electrons, and or rather like when you it can like share electrons, but in the sense like being like whether polar or like we're going to talk about this in more. But it gave carbon like characteristics that we're going to discuss in this course. Any questions? Good so far? Okay, so this sentence is really important in the lecture that I prepared for today that I'm not going to go through because we're running out of time. I emphasize on this a lot. This is really important. Carbon and hydrogen have nearly identical electronegativities. So the carbon-hydrogen bond is almost purely covalent. It means that it's not polar, right? So if you go to the electronegativity table, they have like slightly different, electronegativity, and I have like the similar. So for that matter, this bond is not polar, or we consider that being non-polar. Does that make sense? And which of the following would you expect to have polar covalent bonds? You see, we say covalent bond. So if you see metal, non-metal, what bonds do they have? Ionic, so they're not covalent. And if you see the element, just one element, like N2, F2, what type of covalent bonds do they have? Non-polar. So this is the only polar one. And this was kind of like review of the previous one. Which of the following is not correct about the formation of hydrogen molecule from hydrogen atom? The reaction is exothermic. It releases energy. Endothermic absorbs energy. Okay? So go through this slide that I posted before and kind of like review this one. The main component of petroleum and natural gas resources that now supply most of our fuel are hydrocarbons, right? So here. Based on what you learned in CHEM275, how do we categorize hydrocarbons? Based on type of carbon-carbon, whether it's like single bond, double bond, triple bond, right? Not number of carbon. Here, these elements, these compounds, they have like different number of carbon bonds, but still we call them alkanes, right? So remember, based on type of carbon-carbon bonds. What does the following definition represent? I have still 2 minutes, so bear with me. A special class of cyclic compounds related in the structure to benzene. What was it? Aromatic, right? Not the other one. What are saturated hydrocarbons? They have only single bonds. What are unsaturated? They can have double, they can have triple, right? So, through number. And the blank of an alkane is that of the longest continuous chain of carbon atoms. Root name, okay? To like go most, So I highly encourage you to show that. So, carbon, hydrogen. One of them is 2.2 hydrogen, the other is 2.5. So they are different, but they are like slightly different. We consider them to be where I had to watch. I encourage videos that I encourage to go through. I post here and some video slides, especially that some references I prepared for today.